Mole concept. In this module, we will study about atomic mass, molecular mass, formula mass, molar mass, mole concept, Avogadro's number, and some important formulae. An introduction.
As we know, objects are generally measured by counting or by weight. It is easier to measure large objects like elephants, cars, and eggs by counting. However, it is convenient to measure small objects like rice and butter by weight. For counting common objects, we use a pair of shoes. However, 10 grams of gold coin has billions of gold atoms.
Before discussing about mole, let us understand some basic terms like atomic mass, atomic mass. In the 19th century, scientists adopted a comparative method to find the atomic mass.
Atomic mass of an atom is a number that compares the mass of a given atom with the 1/12th of C12 atom. One atomic mass unit is defined as the mass exactly equal to 1/12th of the mass of one carbon-12 atom.
Consider the following example. One atomic mass unit is equal to 1.66056 into 10 raised to the power minus 24 grams. Mass of hydrogen atom is equal to 1.6736 into 10 raised to the power minus 24 grams. Average atomic mass. Many naturally occurring elements exist as more than one isotope. On taking the account of these isotopes and their percentage occurrence, the average atomic mass instead of atomic mass is considered. To calculate the average atomic mass of an atom, exact atomic mass of its each isotope is multiplied by its percent abundance. The results are added together and rounded off to an appropriate number of significant figures. Calculate the average atomic mass of carbon from the given table.
Molecular mass is the mass of the formula unit or sum of the atomic masses of the atomic species as given in the molecule.
Calculate the molecular mass of methane. Formula mass.
Formula mass is the sum of the atomic masses of the atomic species as given in the formula of the compound.
For example, The formula mass of sodium chloride is expressed as the sum of atomic mass of sodium and atomic mass of chlorine. Let us calculate the formula mass of sulfuric acid. "98 grams of sulfuric acid is equivalent to 1 mole of sulfuric acid. Molar mass.
Molar mass is the mass of 1 mole of a substance in grams.
Mole concept. In the SI system, a mole is the base quantity for the amount of substance. So you must be wondering how big a mole is. A mole is a collection of 6.023 into 10 raised to the power 23 particles. These particles may be atoms, molecules, ions, or electrons. 1 mole of marble would be enough to cover the entire Earth to a depth of 50 miles. If the entire population of the Earth were to do nothing but count atoms in 1 mole of an element 24 hours a day at the rate of 1, yet there is just 1 mole of water molecule, that is 6.023 into 10. A mole is a large number because atoms, molecules, and formula units are quite small. In order to have useful masses in lab, we have to use moles of those substances.
A birthday party will be without balloons. We can easily count the number of balloons used in a birthday party. But can we count the number of particles of gas present inside each balloon? Let's try. This balloon is filled with oxygen and this one with nitrogen. If the volume is same in both of them, then which one will have more number of particles of gas? The answer to this question can be given with the help of mole concept. Mole concept was given by Amedeo Avogadro, which states that equal volumes of gases at the same temperature and pressure contain equal number of molecules. Let us find 1 mole of which of these gases, hydrogen, ammonia, and carbon dioxide, has more number of molecules. It is observed that 1 mole of all of these gases have 6.022 into 10 to the power 23 molecules. Let us try to find 1 mole of which of these gases will occupy more volume. Since the volume of substance changes with temperature and pressure, we measure the volume of all the gases at STP, that is 273 Kelvin and 1 atmospheric pressure. First, we will measure the volume of 1 mole of hydrogen gas. You will observe that it occupies 22.4 liter at STP. When we measure the volume of 1 mole of ammonia gas, we observe that it occupies 22.4 liter at STP. Similarly, when we measure the volume of 1 mole of carbon dioxide at STP, it also occupies 22.4 liter. Let us weigh 1 mole of each of these gases and find if their weights are also identical like their volumes and number of particles are. First, we will find the weight of 1 mole of hydrogen gas. It weighs 2 grams. When we weigh 1 mole of ammonia, it weighs 17 grams. When we weigh 1 mole of carbon dioxide, it weighs 44 grams. The following equation shows how 1 mole of substance is related to the number of molecules. Volume of substance,
Avogadro's number. The number of particles in 1 mole of a substance, whether an element or compound, is known as the Avogadro's number. It was found by Amedeo Avogadro. The relationship between the gram atomic weight and the Avogadro's number for some common elements is as follows. Important formulae.
Some important formulae related to mole are as follows. Here are some important relations for solving questions. Some more important relations useful in the calculations are as follows.
Let us solve a numerical. Calculate the number of each kind of atoms in 5.5 grams. Now 1 formula unit of sodium carbonate contains 2 atoms of sodium, 1 atom of carbon and 3 atoms of oxygen. Therefore, the number of sodium atoms in 5. Let us solve another numerical. A cylinder contains 0.30 grams of ethylene. Calculate the. Let us begin with the first part. The molecular mass of ethylene is 28. Now we will solve the third part. 1 molecule. Let us solve one more numerical. How many gram molecules and grams of ammonia are present? Now we will calculate the gram molecular mass of ammonia, which comes out to be 17. Therefore, 1 gram molecule of ammonia. It's time to test your knowledge. Complete the following. Avogadro's number represents the number of atoms in. The options are A. 12 grams of C12, B. 320 grams of sulfur, C. 32 grams of oxygen, D. 12.7 grams of iodine. Complete the following. 1 mole of water corresponds to which of the following options? A. 22.4 liters at 1 atmosphere and 25 degrees Celsius, B. 1 gram, C. 18 grams, D. 6.02 into 10 raised to the power 20. From the given options, identify the number of water molecules present in a drop of water weighing 0.018 grams. The options are A. 6.023 into 10 raised to the power 26, B 6.023 into 10 raised to the power 23, C 6.023 into 10 raised to the power 20, D 6.023 into 10 raised to the power 90. Complete the following. 1 mole of oxygen gas is the volume of, and the options are A. 1 liter of oxygen at STP, B. 22.4 liters of oxygen at STP, C. 32 liters of oxygen at STP, D. 6.02 into 10 raised to the power 23 molecules of oxygen. Let's have a quick recap. The atomic mass of an element is expressed relative to C12 isotope of carbon, which has an exact value of 12U. Molar mass is the mass of 1 mole of a substance in grams.